you. Let me get rid of my. What's with the pipes, DJ?
I don't know. I've been working out.
Working out. Are these yours?
The pipes?
Yeah. Did you work? No, seriously, were you bending it?
Well,
Okay, if I guys can have your attention, my friend. Topic today: adjustable circuit breakers. We have it. If you guys go to Article 240.6b, Article 240.6a will tell you the non-adjustable circuit breakers. We all know that we can go from 15 all the way to, what is it, 6,000 amps. Adjustable circuit breakers, you can go to a lot of adjustments. So to understand, guys, adjustable circuit breakers, if you're dealing with 1,000 amp or higher, most likely you are dealing with an electronic circuit breaker that looks like this. That's adjustable. For adjustable circuit breakers, Brad, here's what you're going to have. You're going to have multiple settings, and very important to understand it. The first size for it, it's called frame size. The second one is sensor size. The third one is plug size. And the fourth one is settings. So for every electronic adjustable circuit breakers, you're going to find, most likely, you're going to find these 4 settings or sizes for the electronic power adjustable circuit breakers. Unlike the non-adjustable circuit breakers, guys, you're looking at them right here. It's 15 amp is a 15 amp. Just one size, 15 amp, 15 amp. Okay. So let me just tell you a few things, guys, and I'm going to take an example about this one. The first thing, a frame size, and to help me with this, guys, I grabbed, if you have a Cutler Hammer book, a book like Cutler Hammer here, and if you guys go all the way to page 27.1-7, you're going to have that Magnum DS switch gear. They have a switch gear that's called Magnum DS. This is a Magnum DS, or similar to a Magnum DS power circuit breakers. Power circuit breaker. Just to give you an idea, industry-wise, where we do find something similar to this. We will be using this one, guys, in Power Tools for Window next week when I walk you through the coordination. I'll be using this particular Magnum power, Magnum DS power circuit breakers from Cutler Hammer. Okay, let me just tell you a few things, Cutler Hammer. The first thing you need to do, if you're looking, there's a frames, you can go frame-wise from 800 all the way to 6,000. I picked a frame of 3,200. So for example, the frame for this one will be 3,200 amps, the frame size. So Brad, when they ask you about the frame size, a 3,200 amp frame size. The second thing that you can have as a sensor, frame size, you can do sensing for the frame size. A sensor, you can make it sense at, let's just say 3,000 amps. 3,000 amps. So my sensors, if you guys look at my sensors are the CTs that attach to this circuit breaker. Let's just use, instead of a 2,000, make it more realistic. Sensor, let's use a 2,000. I want to sense at 2,000. What does that mean, Brad, here? The CTs that comes with the adjustable circuit breaker are 2,000. So you're limited to 2,000. Even though the frame, the box, a frame, guys, is just a frame. The physical dimension of the circuit breakers is rated for 3,200. So I can physically unplug this circuit breakers, unplug up to 3,200 circuit breakers in it. Okay? So that's my sensor. The plug, now I took the frame 32, I reduced it to 2,000 because I care less about, I don't want my system is up to 2,000, and then I can reduce it more, guys, by putting a plug. So these are the CTs. That what you're looking at here is a plug, a tiny little device, guys, that you can literally, physically, in the face of the circuit breaker, plug it and change the setting of the circuit breaker. So the plug, I'm going to plug this baby at 1,000 amp. So now you're looking at a 3200 frame that has been reduced to sense up to 2000, and also with a plug, which is another reducer, reduced to sense to a 1000. So basically what you're looking at right now, for all practical reasons, it's a 1000 amp circuit breaker. Does that make sense?
An expensive 1,000 amp circuit breaker.
An expensive 1000 amp circuit breaker. It gets even more interesting. So we went from a frame to a sensor to a plug. Any question guys about the frame size, the sensor size, and the plug? So reducing, and to understand why they do it this way, guys, it's unreal. It allows you flexibility in the future expansion. I can go right now. My switch gear is a 1000 amp. In the future, I want to make it 2000 amp, no problem. I don't change the switch gear, guys. I go plug. I put a 2000 amp plug, and this circuit breaker will change into a 2000. I have to re-cable it. I have to pull new cables though. Okay, long time pickup, long time delay. We talked about this one, guys, before. The long time pickup, I'm going to give you a couple of settings for the long time pickup. Let me put them here. I'm going to put the 4 here, the short time delay. 5 instantaneous, and 6 round. And I'm going to delete these just to give you the adjustment here, and then we'll take an example calculation. Okay. So for long time pick up. Long time pickup. For long time pickup, guys, you can go a lot of time, most of the time, you can go from 0.4 all the way to 1. So, for example, DJ, if I want to make this circuit breaker a 400 circuit breaker, you know what I do? I just put the settings at 0.4. So 0.4 times 100, 1000, they'll give you 400. So that 3200 circuit breaker turned into a 400 amp circuit breaker. Unreal. One more time. I have a 32 frame that open it for future expansion. I sense at 2000 amp to reduce my price at day one. I plugged at 1000, my 1000 amp plug, because I really don't care at this point for higher than 1000 plug. Then to reduce it even more, I went and I can adjust down to 0.4 settings, 0.4, 0.5, 0.6, 0.7, all the way to 1. And that will give me, if you take 0.4 Brad times 1000, it'll give you 400 amp.
Yes, it will.
So that's how good this would be. So that's short time pickup. Let's talk about short time. And we drew that one, guys. Remember how we said the settings of the circuit breaker all the way. There you go. That's the stuff that we were, and that's what you guys are going to be doing with your friend Chad. This is long time pickup. Let me just draw them here one more time. Long time pickup. This part is short, long time delay, the delay part of it. Long time delay. And this will be, we need a piece. Straight piece here. There you go, and then a piece like this. So that will be a short time pick up. This will be short time delay, and the last piece will be my instantaneous. This piece will my end instantaneous. This is what you guys are going to be looking on Monday when we look at this circuit breaker. You're going to be looking at a curve that looks like this. We drew that one before, so long time pickup, long time delay, short time pickup, short time delay, and instantaneous. Okay, let me go, guys, to the long time pickup. I have a setting for the long time pickup. I'm just going to throw these. So any question, guys, about long time pickup? That's what's going to be sitting this piece here. And oh, by the way, that will decide the size of the circuit breaker, as you're going to see in a second. So short time pickup, guys, you can go from 5 all the way to 20.
that?
5 all the way to
time
20.
pickup or is that long time delay?
Long time delay, thank you. Short time pickup is the other side. Long time delay, that's a time. So when we go long time delay, you can, I'm just going to say you can go from 5 seconds to 50 seconds here. 5 to 50 seconds. You allow 5 to 50 seconds for the circuit breaker to trip. Short time pickup, I'm going to say 5 all the way to 50. And you're going to see guys in a second what we're going to do, 5 to 50. And short time delay, what do I have for short time? Short time delay, I have from 1 to 3 seconds. Short time delay. Instantaneous is instantaneous. Instantaneous, I'm sitting at 35. And a ground, the ground fault protection, I'll show, I'm not going to put the setting for it, but that's just looking for a ground fault protection.
35 seconds?
No, these are pickup 35, there is no delay on it. That's instant, 35 times the full load current. You're going to see in a second. Any question guys about all these settings? Let me repeat myself one more time. When you have a power electronic circuit breakers or electronic circuit breakers, you're going to have 4 sizes for it. Size number 1 is the frame. That's as high as you can get without changing the structure of the switchgear. The second one is the sensor. That's you can reduce the frame size because you don't need that much amp, 3200, by putting CTs inside the circuit breaker to reduce it down to 2000 because I don't need more than 2000. Then allows you to plug in right in the face of the switchgear. I don't know if you guys, when we went to Allianz, if you saw where they have tiny little plugs right in the face of the switchgear, unplug and plug in, very easy. You can plug and unplug, and that plug allows you to reduce even more to 1000. And if that's not enough for you, Camille, my friend, you still can reduce by the settings. Then you have all these dials here, dial button here that you can with a screwdriver by looking. If you guys look at the IEC contactor, there has these dials, and you can adjust them by taking long time pickup from 0.4 to 1. Delay, you can delay the trip up to, I'm just throwing these numbers, these are different from one manufacturer to another, 5 to 10 to 50. Short time pickup 5 to 50, short time pickup, and the delay is 1 to 3, the short time, and the instantaneous 35. The ground, we can set the ground at, I'm not going to mess with the ground setting at this point. That's just for the ground setting. Any question, guys? Any question about this? This, you are looking at 240.6b. That's what an adjustable circuit breaker is. We have never touched on that. We always go to, if you guys remember, we always go to 240 and we just say 240. We don't say 240.a. Most of the time we're in 240.a. And if you're looking at in Brad, the 240.a, they are non, it says non-adjustable. Doesn't apply to this. B is the one that applies to adjustable circuit breakers. Okay? Here's what I'm going to do. I'm going to go take, I'm going to go size these and find the amp size for all these stuff, guys, that you're looking at. So I want to take the frame size. Any question before I go to calculate? How am I going to be testing you guys in this? There will be a calculation example where you have to find the long time pickup, short time instantaneous in amps. That's basically what I'm going to be doing now. Okay, here's a question. Based on this adjustable circuit breaker, power circuit breaker, I want you guys to find the following. So I'm going to call this one example 1. All this is going to be example number 1. And knowing all this, I want you guys to find the following. Knowing all this, I want you to find the following. Okay? Everybody can see that? Any question, guys, about the adjustable circuit breaker settings? 4 sizes, and then there's 6 settings under one. The setting size, there's 6 things you have to adjust. On Monday, we will be using PTW, guys, to do the adjustment for these, so that will help you a lot as you look at this, the long time pickup, long time delay, short time pickup, short time delay, instantaneous, and they are right here. These pieces, as you guys can see. So this one will be my number 1 here. This one, the delay is going to be my number 2. And number 3 is here. Number 4 and number 5 is here. And if you have a ground fault, the ground fault will be separate piece. This will be ground fault. This will be my ground fault. And that will be my number 6. It's a separate piece. A separate piece. Completely separate from the other function. And you're going to see it, guys, on Monday when we do the power tools for window coordination. Any question, guys, about if you are to work for an engineering firm or high profile jobs and you don't understand these, you get very confused. We were just talking about, guys, Mashad Cooley, you and I were talking about Mashad and how they have their own standards, that if you have this switch gear, you can use this circuit breaker, but they don't tell you in the standards that there is adjustable circuit breakers that I can use a 3200 amp circuit breaker and make it 1000 amp circuit breaker without changing anything other than a couple of plugs in the circuit breaker. Unreal. So adjustable circuit breaker, guys, give you the ability to grow with the load. So instead, if it's non-adjustable, and then I want to start with a 1000 amp non-adjustable circuit breaker here, guys, I'm going to move to a 2000 amp. You know what that requires you? Basically redesign the whole switch gear and basically messing around with the structure of the panel board. You have to redesign the whole panel board. If it's adjustable circuit breaker like this guy, all what you have to do is just change the plug. And you can't change the plug to every other. There's certain plugs that you can plug. So they give you, for example, for plugs, they give you a 1000, an 800, a 2000 plug. So there's certain, and if you guys go, if you want to know an example of a good plug, it's 27.1-7 in Cutler Hammer book here. It shows a Magnum DS circuit breaker with the available plugs with it. So you almost have to go to the manufacturer's literature to find the right plug for it. For example,
which bit?
this is 27.1-7. So let me write it here. 27.1-7. Cutler Hammer book. 27.1-7 talk about Magnum DS cable circuit breaker and the available settings for it. For example, I'm looking at this, and GE guys have theirs, which is very similar. So for example, for Cutler Hammer, they start with here's the frame that they have. You can buy Cutler Hammer, 800 amp frame, or you can buy a 1600 amp frame, or a 2000, or a 32, or a 4000, or a 5000, or a 6000. That's it. These are the available frames. Then for plugs, sensors and rating plugs, for sensors and plugs, they can, the 800, just the 800, you can plug them or sense them at 200, 250, 300, 400, 600, or 800. That's it. You can't go in between. Settings, though, that's the plug. Settings, you can, most of the time, you can go from 0.4 all the way to 1. So, let's take an example. Any question about these settings, guys? I'm telling you guys about the plugs for this 32 frame. If you look at the plugs for this 32 frame, Brad, unreal. They start for this 32. I can plug the 3200 at 200 plug, 250, 300, 400, 600, 800, 1000, 1200, 1600, 2000, 2500, 3000, and 3200. These are the available plugs for this circuit breaker from the manufacturers. I can easily make this one a 200 amp just by plugging in a 200 amp plug here. I don't know if you guys see the gravity of the ability for you to design anything you want with these circuit breakers. You're no longer stuck with the non-adjustable where you have to go up and you have to go down and all this good stuff. Now you can design a circuit breaker that matches your load. Okay? Let's take an example. How do you size them? A quick example. Any question guys about this? So please look at the frame size 3200, the sensor 2000, the plug is 1000, and all these settings. And I'm going to be asking you 4 questions about this particular circuit breaker. We're going to answer them. Very easy. There's not a whole lot of math, Ryan, my friend, involved in it at all. Okay, here's the question number 1 I want to ask you guys. Number 1 is, I want you to find find the following. Find the following for the circuit for adjustable circuit breaker. Find the following for the adjustable circuit breaker. So, Bill, my friend, you can give this material to the electrician in the field and they go literally physically adjust the circuit breaker. That's what we're trying to do. Number one, guys, is long time pickup. Long time pick up in amps. If the setting, I'm going to go set it at 0.5. I'm going to go set it at, and knowing that setting, right now I'm sitting at 0.5. So I set the long time pickup at 0.5, and they want me guys to find the amp size then. What's the amp size for the long time pickup? Here's what you do. You take, what's the setting, guys? 0.5. So you take the 0.5 times plug amp. The plug amp. Very important which amp you use, the plug amp. So Brad, what was the plug for this baby? We plugged it at 1,000, so 0.5 times 1,000. From the get-go, I have a 500 amp circuit breaker. So now my circuit breaker that has a frame of 32, a sensor of 2,000, and a plug of 1,000, turn in a magic just by flipping the screwdriver like this. I changed it into a 500 amp circuit breaker. Unreal. So, the most important thing about this, guys, now, if I ask you, how do you size the cables to the circuit breakers based on which amp? The long time pickup. That's the most important thing. I can go and size cables based on the long time pickup. So here's just to give you an idea. Here's my, now this circuit breaker, it has a 3200 amp, and it has also a 1000 amp, and it's sit at 500 amp, right? Now my question for, look how many amps this sucker has. Which amp would you use to size the cable for it? The 500. That's the most important thing about the pickup. Very interesting. So Brad, do me a favor, and can you get me the size for a 500 kcm? What would that be, 600? So let's just say 4 conductors, number 600. Would that be 600 kcm? Right? Can anybody verify that one? 600 maybe?
500 amps would be
900.
900.
900? Oh boy, I was off by a while, huh?
So
900.
you're showing us this great technique for making a 3200 amp size down to 500, and you're saying that it's great because it's going to let you expand when it gets bigger, blah, blah, blah. But you're still going to have to pull a larger conductor.
No.
Why wouldn't you?
No. That's the key point. You still have, but if I don't,
It's only good for 500 amps. That conductor is only good for up to 500 amps.
yes.
So if you go to 1,000 amps, then you're going to have to pull a new conductor.
Yes.
So it's
But in
a
a switch gear though, in a switch gear, guys, pulling in new conductors when you size the conduits, the right conduit, piece of cake. You can pull the conductors when the switch gear is hot.
So I'm going to size my conduit for 3,200 amps, but I'm only going to pull a 500 amp conductor in the conduit.
That's what I would do. If I know, that's exactly what I would do. But I pull only one conductor on it.
Right, but you're still.
Yeah, you still have to. Yeah.
You would have to do a cost analysis to find out how much a 3,200 amp
Yeah.
breaker is going to cost you as it relates to. Because if
Yeah.
I'm pulling
You
ground, then I'm
You really have, yes, there is a cost analysis. Sometimes this is not the best example in terms of using a 3200, but I tell you what, if I need, I can use a 3000 frame if I need 2500 amp. And in the future, I might go to 3000 amp. That would be a good idea to use 3200.
I'm just.
I see your
From
point
a-
though.
From
Yeah.
a money standpoint, I mean, you're gonna have to work within the boundaries of what people are giving you for money. It's not like you just have a blank check to say, oh, we're gonna spend this much money on a 3200 amp, even though we're only
And that's-
gonna use 500.
You're absolutely right. That's where value engineering comes. That's where value engineering comes. Value engineering to take a 3200 frame and break it 500, it is not the right way to do business. But I tell you, 3200 amp, breaking it into having a plug of a 2000 amp here, a sensor 2000, and plug it at also 2000 and tweak it down to 1900. That might be a good idea because it allows you to go to 1900. There is no 1900 circuit breaker though. See, the key point is when you go higher in the amps, the jump is the gap between the standard circuit breakers are wide.
Right.
That allows you to bridge this gap.
In this particular example, isn't it a little bit dangerous to have a breaker that's adjustable?
Thank you.
From 500 to 3, because if somebody turns that, then you're going to break.
Thank you. There's rules for the code. In order to size based on the long time pickup, the adjustment have to be locked behind closed doors, the buttons here, or the room has to be locked and only authorized people are allowed to walk in. Like the room that we walked in, guys, those are inside that room, they're all electricians and only authorized people can walk in because you don't want somebody with a screwdriver start tweaking them up and down. You're absolutely right. It has to be either locked with a lock and only authorized people can open the panel, or the room itself have to be locked and with authorized people. You're absolutely right. I can't put this one in a hallway of a school and leave it open. Absolutely, you're absolutely right. It has to be access to the settings have to be only for authorized people or qualified. They call them qualified people. Any question? Guys, see the power of long time pickup. I took a 3200 amp circuit breaker and I sized it based on a 500 amp. That's it. That's the most important thing about what I want to be saying today. Yes.
Well, I guess another question along the same lines is, if you're adjusting it down to 9, we'll say to 500, right?
Okay.
Where we're at, and it's locked. Could you pull a larger conductor, since it's locked anyway, right? Could you pull, say, could you parallel 2 900s then?
Yes.
To give you whatever, and then.
For future expansion?
Right.
Yeah.
You could pull it right up front.
Oh, I can pull all the sets. I can size the conductors all to 3200.
What does that do for your
But it defeats
coordination?
it defeats if I pull the conductors but not use them.
Right.
It defeats the purpose of having the adjustment to start with, because the adjustment is there to reduce the number of conductors.
But you could reduce it down with the circuit breaker.
I know, but
I'm just saying, if you know that in 5 years
it wouldn't
you're gonna
change.
be
Thank you.
larger.
When you do the coordination, if you set this one at a 500 amp because that's what your load is,
Mhm.
the reason why I would do that, guys, by the way, why would I do that? Because this is tied to a 500 amp panel. That's what I would do. It's tied to 500. I don't need 3200 amp to feed a 500 amp panel or a chiller. Now, if that's the situation, I pulled 10 runs of 500 based on 32, and all tied, there's lugs enough for them in the back, and I'm only sizing it to 500. For my coordination, this circuit breaker is a 500 circuit breaker. We don't care about the cables on it. Good point. But it really, as I said, defeats the purpose, because the reason why we're tweaking, because we don't want to pull cables. Imagine the amount of money that you save by not pulling sizing based on 32 with future expansion though. It allows you, your conduits are ready to go. Whenever you expand, you just pull new conduits. It takes you, with the switch gear, guys, literally, it will take you probably 2 hours on a weekend, shut down the switch gear and go pull new cables. The conduits are there, tie them from both ends. Within 2 hours on a weekend, you have turned a 500 amp into a 3200 amp within 2 hours. If that wasn't designed this way, you have to custom design, screw up the whole switch gear. It will take you at least a week, and plus the whole mess with fitting new equipment. It's a mess, and more expensive too. Any question, guys, about long time pickup? The most important thing that I'm going to say today is that one, number one. Long time pickup, you size the cables based on it. Done. Everything else is really not important in terms of sizing. It's very important in short circuit coordination. Very important short circuit coordination. So please write yourself, this is the single most important thing that basically when you size, it's going to, from a sizing design point of view. Any question, guys? Any question about this? Please write yourself the formula on the test. Please write the sitting, long time pickup sitting times the plug, not the sensor, not the sensor, not the frame, right? So Jim, my friend, I can't go to 0.5 and multiply it by 3200 or 2000. And actually we forgot the sensor here. We have a sensor of 2000 too. So I have 3200, 2000, 1000. Which one am I going to be plugging in here? The plug amps. Very clear. The plug amps. Any question, guys? Any questions? Let's go to the second one. The second one, 4 things, by the way, I'm going to size. Just give you a heads up. I'm always sizing 4 things. Number 4, Mr. Bell. Short time pickup. I want you to.
Number 4.
Number 2, thank you. Number 2, short time pickup in amps. I want you to find the short time pickup in amps. But I need to give you the setting, guys. Setting. If the setting is short time pickup. If the setting is 15. It's set at 15. Meaning you guys tweak it with a screwdriver to the 0.50. Find how many amps short time pickup is. Short time pickup is a short circuit. How fast on a short circuit this circuit breaker will trip. So in terms of sizing, it's meaningless. In terms of coordination, big deal. In terms of coordination, big deal. Here's the rule for it.
Excuse me, is that 15? Is that 15? What is it? Is it second?
15 multiplier, just 15.
Second?
No seconds.
Oh,
That's pickup. That's like
Just multiply.
multiplier.
Oh.
Yeah. Thank you. 15. Okay. So here's the rule. To find the short time pickup, the rule, my friend, is you're going to take the setting, which is 15, and you multiply it by long time pickup. Don't ask me why. That's how they size it. You multiply it by long time pickup. Did you guys see that? Very important. Write this rule. You don't multiply it by the plug, the sensor, the frame. You only multiply it by the long time pickup. So based on this, that's a rule. So short time pickup equal 15. 15, Mr. Irbab, is the sitting. So on the test, if I give you the sitting, guys, is 10. You just multiply by 10. What's the long time pickup that we guys came up with? 500. Anybody has a calculator handy? $7,500. 7,500 amp. Now I can't emphasize this value is meaningless in terms of sizing. It's meaningful when we do short circuit coordination. Okay? Did you use a calculator to find the answer, or you just
No, I just took 15 times 5, which is pretty simple math.
15 times 5?
15 times 5 is 75, and then you add your 2 zeros.
He's good. He's good.
A lot of years making change, chap. A lot of years making change.
Yeah. It's a challenge that I have with my wife. I'm a calculator guy. So maybe that's my weakest link, whatever you want to call it, but math to me is not multiplication. Multiplication is a whole different issue. Number 3. So this is the short time pickup, 15 times 500, 7,500. The third thing I want you guys to find is instantaneous pickup. Instantaneous means if all hell break loose and the Russians are attacking us, you're going to throw as many guns as you can. Oops, I'm recorded here. That's what instantaneous is. It's all hell break loose. We have a huge short circuit right in the switch gear. Trip right now. No delay, nothing. Right on the spot. Trip. So let's do instantaneous. Instantaneous pick up. Instantaneous. I need to give you the setting, guys. You can't do it without giving you the settings. the settings that I have for the instantaneous, I have instantaneous setup of 30. So Mr. Abab, the multiplier is 30. The instantaneous pickup is 30. Instantaneous pickup is 30. I need you to find how much instantaneous pickup in amps. Find in amps. How much amp does it take for this circuit breaker to trip right on the spot without any delay? Right on the spot. No delay. That's what instantaneous is. Here's the formula, and the formula is weird. Please write it down, because otherwise you wouldn't know it. It goes by 30, which is the multiplier, times plug amp. Don't ask me why. They go by the plug amps. Here's my instantaneous. They go 30, which is whatever setting you guys put here, times the plug. Times the plug, not the sensor. The plug, not the frame. The plug. So based on this, instantaneous equal 30 times, what's the plug, guys, that we had? 1,000. The plug is 1,000, and then that will get me 0 and kiloamp. That's an easy math, Brad. You're not gonna get me.
That is easy. Yes, I agree.
Right? So 30030. So that will give you a 30K. Now, if I use a calculator for this, that would be hard. 30K.
We already won.
Any question, guys? What does that mean? Means all hell break loose. I have a 3-phase short circuit in the switch gear. Is going to trip the amount that will trip the circuit breaker. If I set it at 30, it's going to be 30 kcm. If it sees 30,000 amps, means all hell break loose and trip, no delay whatsoever. No delay whatsoever. While if I didn't give you guys a delay, a long time delay, I can make the circuit breaker wait for 20 seconds before it trips. I can make, no, that's short time delay. Short time delay, I can make it wait for 3 seconds, 4 seconds before it trips. On a long time delay, I can tweak the circuit breaker to trip at, say, 20 seconds, 50 seconds, 60 seconds, long time delay. That's overload. Overload. The last thing, any question, guys, about that? Any question? The last thing that I'm giving you here is number 4, instantaneous time to open circuit breaker, knowing the following. You have to know this though. Knowing that my instantaneous time is set. This is a setting, guys. Setting. I did my instantaneous setting, adjust it to, let's say, to 20 cycles. I want to warn you, this is a time. What happened, guys, to the instantaneous, sometimes Brad, to coordinate, they take the instantaneous, I hate to say it, but they delay it. They actually, instead of tripping right on the spot, they say, okay, but look at the time measurement unit. The unit, when you deal with the instantaneous, guys, we don't deal with seconds. We deal with cycles, because that's fast. That's how fast it is. We deal with cycles. How many cycles we want to ask this circuit breaker to wait before it trips? Cycles, not even seconds, not delay. It's a cycles. So instantaneous time to open circuit breakers. What's the instantaneous time to open the circuit breakers in seconds? What's the instantaneous time that it will take this circuit breaker to open instantaneously if I go to the instantaneous time and adjust it to 20 cycles? Very easy. I'm asking you, how many seconds is 20 cycles? So, the answer would be for this, my friend, is you're going to take 20 cycles divided by what? 60. And that will give me what? 0.3, right? 1/3, which is like 33 seconds. Right? Did I do it right?
Yeah.
Seconds. Does it right here. So that will be equal 0.33 seconds. Any question, guys, about this? Any question? So if I go and shift,
20 over what, 60?
20 over 60. Everybody knows why 20 over 60, guys? Because there's 60 cycles in a second. 60 cycles in a second. So 20 cycles over 60, that will get you how many seconds? Seconds. Very easy. How many seconds? Any question, guys, about long time pickup, short time pickup, delay for both of them, and instantaneous? Any question? This will help you a lot to do power tools for window and coordination. If you guys care, we care. I don't worry, but it's up to you guys where you go. As when we guys went to Michelle Cool Erickson, you see how they pigeonhole people in different locations. So if you end up with Revit, you might never touch this one, but this will be a tool that you can use at any time to advance your career in different directions. One more direction to go through. Otherwise, we're going to do it for Chad Curdy and the test, my friend, and we'll move on, huh? Right, DJ? You're going to be a project manager, so you're not going to, somebody will do that for you. Any question, guys, about this? Long time, short time, pickup and delay, and the instantaneous. I didn't do the setting for the ground fault, guys, but when we do the coordination with PTW, it's the same way. You have a pickup for the ground and you have a delay, pickup and delay. I can't emphasize these information that I pulled it from Magnum DS Switchgear Class UL1066, Scalar Hammer, page 27.1-7. If anybody does not believe Chad, you can find this information. And also 27.2-2. There's some setting. It will tell you the long time pickup is set 0.5 all the way to the 1, the instantaneous, and so forth.
27 dot.
Another one is 27.2-2. 27.2-2. What these, Mr. Bab, these will tell you where this information coming when you're in a real situation and you need to size this based on the product, actual standard product in the industry. Scalar Hammer is a good start. GE has the same thing, guys, but that will tell you what are the actual settings. Okay, for example, can I tweak it to 0.33? I can't because it's not an actual setting. There's steps that you can set these circuit breakers. So for example, the one that I'm looking at, guys, you can set it 0.5, 0.6, 0.7, 0.8. I can do 0.85, kind of weird. And then 0.9, 0.95, and 1. That's it. If I want to set it up at 0.75, Mr. Bab, there is no setting 0.75. So either you're going to go 0.7 or you're going to go most likely you're going to go lower, 0.7. Or you can look at different manufacturers. When we do the coordination, Brad, before we do all these, we know which manufacturer we're using and we pull the information from the library. So otherwise, you can't. Any question, guys? That's what I have for you on a Friday. I don't want to do anything else, at least in this arena.